Welcome to your second day of Inforce. I know it's kind of early in the morning, right? But I will promise this session will be worth it to waking up. I promise. I am not an early person as well, but I'm gonna make it work for a while. My name is Ivo Pinto. I'm a solution architect for AWS, and I'm here joined by my colleague Tsuri from AWS as well, and Boozer from Workday. During the next hour, we'll be talking about firewalls for 1 hour, and where to put them, obviously. There are a lot of different types of firewalls with different names, right? Web application firewall, network firewalls, sometimes they are called next generation firewalls, and even some constructs like security groups that are not explicitly called a firewall, but work as some sort of firewall. To make things more interesting, there's also different levels of visibility, different levels of functionality that come from configuration and where you put those firewalls in your network. But don't worry. That's why we've created this session. During this session, you'll see how these different security constructs apply in AWS, what levels of visibility they give you, also what level of applications, like application types they are good for, and all of that in under an hour. How we're going to do it? Well, this is a level 300 session, but we're going to start with architectural constructs, where we will cover these different concepts, like security groups, network firewalls, what do they do at a high level, but then we'll deep dive into specific use cases and how you use them. Both for inbound, which is the main focus of this session, we'll deep dive really a lot there, and then cover outbound, sort of a shallow dive, and give you some homework as well that you can follow up and learn more about. Then, from theory to practice, Workday is going to talk to you about their firewall journey, how they've evolved their security architecture over time to meet the requirements that were changing. And at the end, we're going to give you some bite-sized journey, bite-sized takeaways that you can take home and apply in your own environment. So let's get started with the first pieces of this bigger puzzle, right? Security groups and network ACLs. Most likely you've heard of this, right? These are the most common constructs that people use in AWS. Security groups function as a stateful firewall, right? They work in the TCP IP layer, so that's layer 4. You can take decisions based on source IP, destination IP, port as well. And they are applied at the ENI level. You know, this could be an EC2, for example, but that's where you apply. Typically, they are mandatory for many resources. You know, when you create an EC2, it's mandatory. And you've certainly seen it and certainly used it. Then you have network ACLs, NACLs. I know there's a lot of contention on how to say this name. They are stateless. They are not stateful, like security groups. But they also work in the TCP IP layer, again, layer 4. Unlike security groups, they are not applied at the ENI level, rather than applied at the subnet level. But then, when you move further from these basic security use cases, you might have to apply policy based on something more than layer 4. And that's where network firewall comes in. This is our managed service offering, right? So we manage it for you. It automatically scales up and down, so on and so forth. And it allows you to create both stateless and stateful rules. So it's not a one and done like security groups or network ACLs. It's a choice, right? Likewise, these rules are applied up to layer 7. So from layer 3 to layer 7, you can choose the rules. The way network firewall protects your resources is that it filters traffic in between your subnets. So typically, you would place it in a separate subnet and use route tables to use traffic. However, there are yet another construct, right? Gateway load balancer. This one is one of those that does not have firewall in its name. As you see, just gateway load balancer. And there's a good reason for it. It's because it's not a firewall. However, it enables firewall use cases, and that's why we will speak about it today. What is it? It's a bump in the wire load balancer, so it's a transparent load balancer. You send traffic to it, and it's transparently routed back to its virtual appliances where a policy decision is made. How do you route traffic to it? Again, you use just the subnet route. Why do you care for gateway load balancer in a firewall tool? Well, because this is an easy way to insert firewalls within your traffic flows. And this is especially useful if you have already invested into third-party firewalls. So if you're already invested, you have the knowledge, right, and you have bought them, this is one way of using it. It has more features than just inserting your firewalls directly on the traffic. For example, automatic rerouting of traffic and also health check. So that's something to look out for.
Thanks, Ivo. I'll cover 2 extra tools in your toolbox when it comes to firewalls. My name is Tsuri. I'm a solutions architect specialist, which is a fancy way to say I only know a few services, not all of them, when it comes to AWS services. One of these services that I do know, luckily enough, is AWS WAF. So AWS WAF is a web application firewall, so it does have the word firewall in it, so this is why we're talking about it today. But it can definitely be used as an ingress control point when it comes to firewalling access into your applications. So basically what AWS WAF does, because I know WAF is kind of different, and some people are only network firewall kind of people, so we do take the time to explain what it does. The one thing it allows you to do is to have layer 7 controls over ingress traffic, so you can have your own allow list and block lists configured. You can have them populated automatically through an API call. Another thing you can have at layer 3 is having managed rules when it comes to IP reputation lists, anonymous IPs, well-known sources that you probably want to block or maybe do something with. Maybe you want to challenge them or just flag them for downstream services to be made aware that they are suspicious IPs. And you can also do geolocation-based controls. So you can do country-based or city region-based controls if you want to control whoever is allowed in. So this is at layer 3. When it comes to layer 7, AWS WAF, obviously it's a web application firewall, so it has full layer 7 capabilities. It understands HTTP only, by the way. And you can have either managed rules or custom rules that identify and control what goes into your application. So you can use it in a positive security mode where you only allow specific URIs or host names or whatever it is that you want to allow, or requests that carry an authentication cookie, for example. Or you can use it in a negative security model where you want to block certain pages, certain URIs from being accessed from the outside world. It could be your admin pages or any sensitive part in your application. Other than that, we have DDoS mitigation capabilities built into AWS WAF, so you can create your own baselines and custom rules that control rates in which you are willing to receive requests. They could be as generic as blanket rate limiting rule, saying, I do not want to allow any more than a certain amount of requests within a 5-minute period from any source. So let's say no more than 10,000 requests, or 1 million, or 500, whatever works for your application. And you can also make these rate-based rules more granular, and you can say, I don't want to receive more than X amount of requests coming in, but only if they're targeting my sign-up pages, or only if it's coming from well-known suspicious sources. So you can create your own rate-limiting rules to be as coarse or as granular as you wish. And as a recent advancement, we also introduced the way for you to keep track of requests, not based on IP addresses, but based on pretty much any part of the application. So you can say, I don't want to receive any more than X amount of post requests from anywhere at once without tracking individual IP addresses. Super useful for distributed attacks. Last but not least, AWS WAF also allows you to run 2 managed rules that deal with automated clients, automated actors, namely bots. And we deal with bots in 2 separate use cases. One is abnormal, non-human behavior, these well-known bots that we can detect through a service or through a managed rule that is called bot control. And the other thing we can do in a managed fashion is to control fraud. We can detect anomalous login activities, anomalous sign-up activities. It goes beyond just detecting whether or not it's a sign-up request, but really is the entity requesting to sign up or requesting to log in, is using proper credentials, going through the proper flow, acting like a human. So all of these capabilities are built into AWS WAF, and you can put it, as we'll see later, in multiple places in your architecture as agnostic to the application or as application-specific as your needs are. Another tool in your toolbox is Firewall Manager. So Ivo talked about, later on, by the way, we'll be holding a competition about properly pronouncing all of our names. It's going to be a challenge. The services that Ivo mentioned, as well as AWS WAF, can be controlled through an organizational service called Firewall Manager. It controls multiple services and multiple features. So it controls, obviously, WAF. It can control network firewall. It can control security groups at the organizational level. And when I say control, it can also control some third-party firewall appliances. And when I say control, it can automatically deploy and remediate misconfigurations. So let's say you can easily detect with Firewall Manager whether someone has opened up port 80 to the world on your ALB and automatically slap like an AWS WAF web ACL on it. Or whenever someone opens up SSH port 22 to the world, you can have Firewall Manager detect that, report that, and also remediate that. So remove that offending rule that does not comply with your policy. The other thing that Firewall Manager does, it can propagate all of its findings into Security Hub, so it can allow you to centrally control and view your status across the organization when it comes to ingress mitigation or ingress control. Now, when it comes to network flows, there are three directions or three use cases for controlling traffic, right? The one that we'll be focusing most today is inbound. Basically, that's the most dangerous path because this is where you expose your applications to the bad internet, to the world, and you want to make sure that whoever accesses your applications from the world is the proper people, the proper entities. And we'll be covering a lot around the inbound controls and considerations when it comes to traffic. Another use case is for outbound control. So if you do allow outbound traffic from within your cloud infrastructure to the world, there are considerations to be made about how to control that outbound traffic if you wish. And we won't go into much depth around that, but there are a few slides that Ivo will cover later on. And the east-west use case where you have applications talking to applications or internal users talking to applications, which we won't cover in this session. We will point out the outbound use case in another session that happened yesterday. Ivo will point it out for you for later viewing if you want. So let's focus on the inbound use case, right? This is the meat of this session. So first, when we try and decide what controls do we want to enforce or use, what tools we want to use for controlling inbound traffic, which is also ingress traffic. So we might be using inbound and ingress throughout this presentation. So when we come to choose our tools, the proper tools, or probably tools that control inbound traffic, there are a few considerations that we need to think about. So firstly, what kind of traffic are we dealing with? Is it only HTTP? And then we have a myriad of options and possibilities when it comes to ingress traffic control. We can use WAF, we can use CloudFront, we can use other ALBs, we can use other proxy services that enable us finer control over what comes in, or is it for all application? Do we have like custom ports, custom protocols that we also want to provide inbound traffic to, right? Some use cases are like that. How big are we deploying here? Is it like a single VPC, single entry point, super easy, like, and then the question is kind of moot. We don't really want to go into complexities where we don't have to over-engineer. But if we are built organizationally differently and we want to centralize control over the ingress traffic and allow the application owners to run their own thing, as well as they go through our centralized choke point, the centralized control point, or whether we want to provide services for multiple VPCs, possibly multiple accounts, these are considerations that might affect our decision on what tool, what service we want to deploy. And lastly, how deep is our love, right? How much do we want to take a look into the traffic? Do we only care about IPs and ports when it comes to ingress traffic? Which is fine, I'm not judging, right? Some use cases are like that. We only want to have the IP and port made sure that we are using proper ports, and that's it. I'm sure that a lot of you are using security groups and have been using security groups, and that's it, which is great, that's fine. But if you want like a deeper understanding of what goes into our traffic, whether it's HTTP or not HTTP, we might need to choose something else that could have a deep packet inspection capabilities to allow us better understanding more than just the ports, right? Is it really an HTTP request? What goes in it, for example? Another consideration, or one of the key considerations we will cover today is how do we build our networking traffic flows? So how do we do it? Do we distribute our control points? And again, if you have a smaller footprint, maybe a single workload or a single VPC, single account, that's fine. We don't need to go into complexities and over-engineering. We can have like a VPC with an internet gateway attached to it and security groups, and that's fine. But when it comes to more complicated environments, we might want to choose to have a centralized approach where we control all ingress traffic in a minimal number of places. I wouldn't say necessarily a single place. And this single place or this minimal number of places can contain multiple controls. So we can have a WAF in it, a reverse proxy in it, a network firewall in it. It can have multiple components in it, but it's all centralized and all traffic is flowing through the same choke point. It might be an organizational necessity because maybe the VPC application people are set to roam free in the cloud and they create their own workloads and they can do whatever they want inside the VPC. But if they want to expose something to the internet, they have to go through another organization that basically controls the incoming traffic centrally. It might be a technological effort, right? So your considerations may vary, your mileage may vary in your own organization, but this is one key consideration to think about when you build your own network infrastructure, when you want to control ingress traffic. Why would we centralize? So centralizing your traffic obviously has its pros because we have a single control point, we have a single place to look for forensics, logs, We have a small number of people dealing with all ingress traffic, so we can standardize and optimize our efforts when it comes to controlling ingress traffic. But then, if we only have a single point of failure or a single entry point, it might also introduce a greater risk of a larger blast radius. So if something goes wrong, a misconfiguration, or something goes wrong with our inbound control point, it will affect everybody, all of the underlying services that we have exposed through that. It also increases complexity. Even though, conceptually it has less moving parts, but now we have to deal with routing in between VPCs, right? So we have to deal with where traffic is coming from and where is it going through. When you think about distributed workloads, we only have like EC2s, load balancers, IGWs, a single back and forth flow. And again, even though it has like potentially a fewer number of moving pieces, like one central chunky firewall in the front, it may increase our costs. As traffic traverses more than just a single VPC and has to go in between multiple components, it may increase our costs. But then on the flip side, if we do a distributed architecture, we might have duplicate constructs. So we might have multiple firewalls or multiple WAF configurations, which have a cost attached to them. So again, your mileage may vary, but you should be made aware of these considerations. Let's first dive into the distributed workflow for web applications. So when it comes to AWS WAF, AWS WAF is a service that does not have traffic carrying capabilities, right? It's not a reverse proxy in on itself. We have to attach it to something. The most probable situations that you'll encounter in the wild is when you attach an AWS WAF web ACL or a WAF policy to something like ALB or CloudFront. When we talk about distributed models, we'll typically have a single entry point. So it could be a single load balancer, a single ALB that distributes traffic across your workloads. It could be a single CloudFront distribution with a wildcard associated with it, or it could be multiple CloudFront distributions. Depends on how you control your incoming or your DNS names or vanity domains. But eventually, you'll have a minimum number of people that control a single choke point on incoming requests, right? This is only dealing with HTTP traffic. We're talking about web application firewall, so we only deal with WAF. There are a lot of benefits to running your AWS WAF web ACL as far away from your application as possible at the edge, right, at the CloudFront level, and we'll cover those in a couple of minutes. The centralized model for AWS WAF is where we basically allow one group of people to control a single entry point, which will front all of our applications, right? It requires building multiple moving parts, as mentioned before. So basically, we want CloudFront to send traffic to an ALB or to send traffic to a centralized reverse proxy. In this case, it's an ALB. It could be NLB. And this NLB routes traffic to multiple ALBs behind it. So again, it's a similar concept as the distributed model, but this time we are using a single entry point that controls all inbound traffic. When it comes to AWS WAF policies, and we'll see that in a second, the policy may change if you're dealing with a distributed model or a centralized model, which means that your policy may contain only agnostic elements in it, only elements that do not take into consideration how the application looks like when you're dealing with centralized controls, because your web application firewall will be reused across multiple different applications. So you can't really refer to specific URIs in the application, because your single web application firewall policy will have multiple applications under it. So you'll have controls which are more agnostic. Going back to the distributed approach, you can have the people who manage WAF have a very fine grain over what goes into a web ACL, meaning a web ACL can now contain application-specific controls, like managed rules that only deal with PHP vulnerabilities, or stuff like that. In any case, when it comes to controlling ingress traffic, a web ACL, I will leave you with this image of a sample web ACL that does not deal with any application-level vulnerabilities, right? It's not a typical WAF policy. It's more of a policy that you'll see when you deal with ingress traffic control, and that's it. So you'll be seeing IP-based rules, so IP allow lists and block lists. You'll be seeing maybe a list of countries that we don't want to allow any kind of traffic from. We might also see a list of countries where we want to challenge incoming requests. So suspicious countries, not countries that we are not allowed to deal with, but countries that we don't typically see traffic from. An AWS WAF can present the incoming traffic, incoming HTTP request with a JavaScript challenge, just to make sure that whoever is speaking to us is a proper browser and not some kind of an automated client. And then we can also have managed rules that deal with IP reputation, anonymous IPs. These are managed IP lists that we keep populated for you, and they can track well-known bad sources, like DDoS contributors and botnets and all of these bad sources that you don't necessarily want to allow traffic from into your applications. And then again, you can also add your bot control management rules, which allows you to keep track of sessions and volumetric sessions. And then lastly, you can create your rate limiting rules, which can be as specific or as generic as you wish. If you look at the last rule here, like a blanket rate limiting, I do not want to allow more than X amount of requests from any IP, right? Regardless of where it's coming from or where it's going to. And we can have more specific rate limiting rules that say, I want to be more aggressive with maybe my sign-up page or login page or search page or maybe specific sources. I want to be more aggressive, have lower rates allowed for specific sources or specific destinations at the application level. To sum it up, when it comes to blocking ingress traffic when you have purely HTTP traffic for your application, it makes a ton of sense to push your ACL as far away from the application as possible. Namely, I want to see, whenever it's possible, CloudFront fronting your web application. Because not only will you be benefiting from acceleration, because CloudFront terminates TLS and TCP at the edge at 450 plus POPs around the world, so clients will experience a faster time to connect. CloudFront is also natively filtering out traffic which is not designated to your application, right? It only listens on port 40 and 883. This is no longer your problem to filter traffic which is not pure HTTP traffic. It filters out any non-RFC compliant requests, so nothing which is on port 443 or port 80, but it's not a proper HTTP request. It's just filtered out. You will never see it. It also filters out any traffic which does not match your host names. So any random internet noise, if you look at your firewall logs, at your web application firewall logs, if you're not running on CloudFront, you'll be seeing a ton of traffic that just targets your IP address as a host name. This is just random internet noise. It can be a lot of traffic. CloudFront does not allow this traffic through. It has to have a valid host name that matches your configuration to allow traffic through. Another thing that CloudFront does for you when you enforce application security at the edge is volumetric network-level attacks. Again, network-level stuff is getting managed by the AWS CloudFront team, or the service, rather. We only allow proper HTTP requests. So network-level DDoS attacks like SYN floods, UDP floods, ICMP floods, whatever is non-HTTP, you should not care anymore when you expose your application through CloudFront. Plus, we're also benefiting from a service called Shield Standard, which is our basic DDoS mitigation service, which runs inline, always on CloudFront whenever you enable it. And it also helps with mitigating a lot of the unwanted traffic from hitting your front ends. Even your front-end components, like your firewall, your ALBs, even if you block it at the ALB level, traffic will still reach your ALB if it's just random internet noise. Not so the case where you use CloudFront. We make sure that only proper traffic is going through it before reaching your backend. And with that, I will switch back to Ivo.
Thank you, Turi. So we were talking a lot about HTTP, and web traffic and all of that, but many of you might have other applications, right? Other applications that are not web applications, right? So not HTTP, FTP, syslog, anything like that. If you consider what Turi mentioned before, right, and you think a distributed model for you, right, you could choose a distributed model and the network firewall, right? So with this model in mind, you can support any type of application. You don't necessarily only support HTTP like you did with WAF, so you can filter on anything. And how would you go about deploying it, right? So you just create network firewall endpoints in all your VPCs, hence the distributed environment, and you would use route tables to pass traffic through it, right? It enters through the internet, then network firewall, then there. With this approach, you can also take decisions up to layer 7, just like the WAF, but in this case, layer 7 of all these different products. We recently introduced encryption, TLS decryption capability on the network firewall. So even if your traffic is encrypted, you can provide it with a load balancer, and you'll be able to take decisions and have visibility even on that traffic, okay? The data plane of this solution is distributed, and that's important for the scale considerations, as Suri was mentioning. So this scales very well. It's distributed. Each of its VPCs is going to have its own dedicated firewall clusters, but this will be more clear on the next slide. And from the management perspective, you can either choose to manage it centrally using Firewall Manager, because there's native integration with there. You create the policy, you say which VPCs you want it to use, and it will just deploy it for you. Or you can manage it individually. Let's say each of your teams has its own firewall, has its own rules. They want to manage it themselves. You want to give them that power. You can do so, right? So you would not use Firewall Manager in that sense. However, as I mentioned in the beginning of the presentation, some of you might have already invested into third-party firewalls, right, from some of our partners. And you might want to maintain that, right? You already have trained engineers, and that's fine. So the architecture with gateway load balancer would look exactly the same. Simply the endpoints would not be firewall endpoints, it would be gateway load balancer endpoints. It would still support any type of application. You would still route traffic through using the route tables. However, both the inspection depth and TLS decryption capabilities don't come from the gateway load balancer. Like I've said, come from the virtual appliances themselves. So you'll need to check, right? You'll need to make sure those appliances support your needs. The data plane of this solution is also distributed, right? So you have gateway load balancer endpoints throughout your estate, throughout your VPCs, and they will route traffic transparently to this backend appliance. It's important to note, and again, on the next slide, this will be very visual to understand that with this solution, with the gateway load balancer versus the network firewall, this can airpin to the same firewall cluster, right? So you can have gateway load balancer endpoints pointing to the same cluster. So this solution, when you're scaling it, right, you have to have that into consideration. Lastly, on the management part, you can typically manage this solution via the vendor management tools. So they have their own. This is one way, or just a traditional way, using like CLI, SSH, whatever you like. Now, deep diving on the data path itself, as I mentioned, this is an important consideration, especially for scale and for cost. With the gateway load balancer, you see that you have multiple VPCs with different gateway load balancers pointing to the same gateway load balancer and therefore the same third-party appliances. So although the data plane is distributed, right, they are going to airpin into the same appliances. So if you're scaling it and you have thousands of VPCs, right, all the traffic is going to be hitting the same appliances. So it's sort of distributed data plane in the sense that it can airpin to the same cluster. On the network firewall, however, it's completely different. Each of your VPCs is going to have a dedicated firewall cluster. It will scale individually. So it's fully distributed data plane. It's important to note that this comes with a cost, of course, right? So you're going to have different firewall clusters. It's a more costly model. If you want to replicate the model of network firewall with gateway load balancer, it's possible. You simply have to create, different firewall clusters for all of those gateway load balancers. But let's say a distributed model is not for you, right? Like you were hearing from Suri, you want a centralized ingress point. It could be a requirement for you, could be a compliance requirement. You could just like it, right? It's perfectly reasonable. You can choose to use the same security constructs, network firewall, gateway load balancer. The architecture would look like that. Fairly similar, but there are some considerations you need to have in mind, right? There are some trade-offs here. And although you might pay less in terms of endpoints, right? Because you will have a single endpoint in a single edge VPC, there will be added costs that you need to take into consideration, like the transit gateway, right? All your traffic will be passing through a transit gateway or some sort of mechanism, right, to route traffic from your edge VPC to your application VPC, and therefore there will be processing costs there. It's also worth noting that you will need static IPs for the solution to work because the load balancers in edge VPC cannot point to host names, nor they can point to instance types. Therefore, if you need static IPs, you will need network load balancers on your application VPCs, and therefore you will need to pay for those as well. It's not one-size-fits-all solution. There's nuances here, but these are important considerations to have in mind. On the benefit side, though, right, both of these solutions are centrally managed in the sense that there's a single VPC, single firewall cluster, both gateway load balancer and network firewall. You can just manage it from there. And the previous consideration of data path does not apply here neither, right? Because again, you have a single firewall cluster. But more than choosing centralized versus distributed or gateway load balancer versus network firewall, there's also the consideration that you need to take of where do you place it in your VPC? Do you place it before the load balancer or do you place it before, after? And again, no size fits all. This will affect how you create your rules. So if you put it before, you'll have to create your rules in one way. If you put it after, you need to create rules in another way. But it's all about the visibility that you want to have. So if you put it before the load balancer, you will see all the inbound traffic. You'll see the real source IPs as well, but you will lose the destination IPs because the destination IPs in this case will be the load balancer. On the other hand, if you put it after the load balancer, you won't see all the traffic, right? You'll only see the traffic as set by the load balancer, but you'll be able to see the real destination. It's also worth noting that there's something with certificates here, right? It's a different type of certificate that you need to use with each solution. It's a little bit technical there, but again, have that in mind when you're choosing, okay? So far, this was a big deep dive in inbound. I know it's a lot to take in, right? But I want to switch gears here a little bit to the outbound, okay? Most of the considerations we've talked so far, distributed, centralized, all of that, still applies here, as you can see here. So for egress, that's the same. You'll have to make a decision if you need a single ingress point, or you can have multiple, right? It's up to you. Bear in mind, the considerations about the same, right? So in the centralized, you have a single point, but it's typically more costly, typically more complex. So same as for the ingress. And likewise, where you place your firewalls, in this case, won't be regarding the load balancer. This kind will be regarding the NAT gateway. But they still apply, right? So if you place them after the NAT gateway, you lose the visibility of the source IP. Place them before, you'll see the source IP. Unlike Ingress, though, typically in this outbound scenario, we typically favor the more specific routing approach because there's really not that many trade-offs there. But whatever you choose, just bear in mind that you need to apply those rules for your use case, right? You will have to make your firewall rules use those IPs. But there's a very interesting thing for the outbound scenario that we didn't mention at all for the ingress, right? Which is DNS. Most solutions out there, most instances do not do IP, direct IP communications, right? They first do a DNS lookup that's standard across the industry. And therefore, that's another path that you should secure, right? The DNS outbound path. If you are on AWS, there's also here at play the DNS.2 resolver. For those that don't know what the DNS.2 resolver is, you're likely using it, of course, because that's the default DNS resolver. It sits on the .2 address of your VPC. And unless you change it to something else, that's a DNS resolver used to solve queries. So how can you secure this path? Can you use a firewall? What can you do? I need to introduce to you yet another concept. We didn't do it in the beginning ones because this is sort of a different type of firewall. This is the NIS firewall. What is it? It's an AWS managed DNS firewall. It allows you to block outbound DNS requests from AWS, from your VPC. You can use managed rules, meaning AWS has done for you, or you can create your own if you know your own malicious domains you don't want your users to go to, or simply you can do like a different approach and only allowing specific domains. That's kind of a very explicit approach, right? How does it work? Well, since it's a feature of the Route 53 resolver, right? It's a feature on top of it. If you're already using the .2 resolver, it's very simple. You just have to create these rules, choose which VPCs you want to apply them to, and they automatically are applied before the DNS resolution comes through, right? So your instances goes to the .2 resolver, and the .2 resolver will check first the DNS firewall, and then it will resolve the query. So very simple. But you might ask, well, Ivo, then do I just use it and I don't need to use anything else? No, don't get that message from me, right? This works in parallel. It works in tandem with the network firewall or with other firewall solution. So first, your instance would do the DNS query. It would be filtered on the DNS firewall. And from there, the data path would be filtered on the firewall that you have. This picture is a network firewall, but it could be a gateway load balancer or something, right? So again, they work together. So you secure both paths, the DNS path and the data path. This was a very shallow dive, okay? Like we mentioned, the meat of this session was the inbound one. But I want to refer you back to the NIS305. It was a deep dive, 1 hour deep dive in outbound. So it will talk about all these use cases, DNS, and all of those. There's a small problem here, which is this session happened yesterday. So I guess if you have a time machine, you can go. But if not, I would really urge you to use the on-demand platform to watch it. And a last consideration that I want to talk about outbound before I move on to a summary is that the WAF does not apply, right? If you look back to this picture, you'll see there's no WAF in there. For those that notice it, if you're wondering, the reason is because WAF is an ingress construct, right? So WAF is not used to try to secure an outbound path. Now, this slide, I will not talk specifically about it. What I want you to do, if you have a phone, I see you guys taking your phones out, that's great. That's what I want you to do. This is just a summary, side-by-side summary, so you can compare all of the solutions we talked through minus the DNS firewall, and you can have like a good idea when you're trying to decide on a use case. Where do they apply? What type of path? What type of layer? And what type of feature, right? It's just a refer back to a slide. And now, off to Boozer on his practical uses of this.
Yeah, thanks, Ivo. Hello, everyone. I'm here to, my name is Buzo Okoye, a cybersecurity engineer at Workday. I'm basically here to talk you through our firewall journey, how we moved from different firewall solutions we had in AWS to what we currently have now, and what we plan to have in the nearest future. So about Workday, Workday is a leading provider of enterprise cloud-based application for human capital management, HCM, financial management, product capability, analytics, and reporting tools. And our customers cut across the educational sector, the healthcare industries, financial services, government establishments, and technology companies. My team at Workday is the infrastructure security engineering, and we are responsible for providing technical security solutions for protecting the Workday infrastructure. And this includes the on-prem data centers, the public cloud data centers, and of course, the corporate network. My team is heavily focused on shift-left security. And what this means is that we try as much as possible to bake security into our products from the very beginning of the development cycle. So our initial landing in the AWS cloud, when we first landed in the AWS cloud, considering that we had a working model on premises, and the fact that the cloud was relatively new to most of the engineers handling the project at that time. So we felt that the safest thing to do was to export the same firewall component we had on-prem into the cloud. And with that, we will still preserve the same security posture we had on-prem. And the plan was that as time went on, we will look for ways to improve on this setup. So what was happening at that time is that our design looked more like what you're looking at on the screen. At the upper layer, we had VM load balancers in active HA. And in the middle layer, we had next generation firewalls in active standby HA. And then beneath that, we had auto-scaling group of Kubernetes workers. So what was happening here was that within each AZ, the next-gen firewalls were in active standby, so only one firewall was active at any time. And the result was most of the time high CPU utilization on the part of these next-gen firewalls. We also discovered that the engineers spent quite a good amount of time supporting these firewalls. So we thought that it was about time we improved on this setup. So what we did was, first of all, identify the areas we needed to improve, and then ways to improve on these areas. We identified the CPU memory utilization issue, improve on system availability, and as well manageability and support. The first thing we did to solve the prevailing load issue on the next-gen firewalls was to separate the firewalls based on their functionalities. So we had some next-gen firewalls to handle inbound inspection, and another set of next-gen firewalls to handle outbound inspection. And that helped us to kind of fix the prevailing performance issue at that time. And we also thought that these firewalls should be able to at least scale horizontally with increased load in the cloud. And then for system availability, we thought that we should have these firewalls in active state. They should be able to share state. And with that, if we need to carry out maintenance upgrade on the firewall, we could easily drain a subset of the firewalls in the cluster, upgrade them, and return them back to the fleet without impacting on production traffic. For manageability and support, we started conceiving an idea of having a region-based inspection VPC, where we'll direct all traffic within the organization into this inspection VPC, carry out policy enforcement, and only allow clean traffic in and out. And most importantly, to maintain our shift-left principle, we want dev teams and service teams to be able to manage these firewall solutions. We want to be at the supervisory layer, only ensuring that their design, their deployment are all in line with the Workday security standard. So we had two design options at that time. One was Amazon VPC traffic mirroring, and the second was the gateway load balancer. So the design for the VPC traffic mirroring, interesting traffic from both the ingress and the egress nodes a copy of it, actually, because it's mirroring, is sent to the mirror targets. And this mirror target behind that is scalable, this next-gen firewalls. And with this solution, we are able to achieve out-of-band traffic inspection. The firewall could scale horizontally, which was what we wanted. And this is a very good fit for our region-based inspection VPC. And we will still utilize the rich threat and virus signatures of these next-gen firewalls. But then, here is a problem. We are moving from a solution that allows us to enforce policy to a solution that only detects malicious traffic, because by default, this solution works as an IDS. And as such, this did not go beyond the proof of concept stage. And we were left with the second option, which is the gateway load balancer. I kind of feel that the support for GDIF protocol in AWS was more like a game changer to the way firewalls are currently deployed in the AWS cloud. And in this setup, we direct all outbound traffic to the gateway load balancer endpoint for inspection. We also direct inbound traffic from the public internet to the gateway load balancer endpoint. And beneath that is this scalable next-gen firewall that still had the previous policies we had. We can achieve inline traffic inspection and policy enforcement. The firewalls could scale horizontally, which is what we wanted. But the idea of inspection VPC did not fly because we felt that there could be quite a lot of risk associated with it. So we ended up deploying this solution in the same VPC as our application. And we ended up to achieve both inbound and outbound inspection using the same firewall. So, but then, as time went on, we discovered that we are still maintaining and supporting these next-gen firewalls. Our initial idea of handing off this solution for the dev teams did not really fly, even though we have all automations in place for teams to just plug and play and deploy this solution. But you agree with me that some level of firewall expertise is still required for this. And such, we were still managing this solution. So we felt that we needed something else. We needed a managed solution. We thought we needed a managed firewall at this point. And here comes the AWS Network Firewall. So we had a working application VPC. And how do we get the AWS Network Firewall into our infrastructure that is already working with these next-gen firewalls? So we thought that it would be good to use the centralized model. And what this allows us to do is to deploy the AWS Network Firewall VPC side by side with our application, our existing application VPC. We tune the policies of these next-gen firewalls, carry out our performance testing, stress testing, and vulnerability scanning on the two infrastructure. And if the result looks good, if we have confidence in this setup, then we can make a case to seamlessly cut over traffic to the AWS Network Firewall VPC. And that worked the way we wanted it. And we're able to route traffic from the existing VPC that has our application with the gateway load balancer endpoint to the VPC that has the AWS Network Firewall via the transit gateway. For logging, we are sending logs to CloudWatch. And then from CloudWatch, we are shipping to our Splunk endpoint using AWS Kinesis. In the traffic flow for the AWS Network Firewall VPC, all traffic from our applications are forwarded to the transit gateway, and then from the transit gateway to the network firewall subnet for inspection, and then en route to the internet. The inbound traffic goes the reverse way from the public internet to the inspection VPC, down to the transit gateway, and then onto the application. It's worth it to note that all outbound traffic is hidden behind the NAT gateway within this AWS Network Firewall VPC. Yeah, but what's happening at this point is that the adoption rate for this setup from our service teams and dev teams, we are more like about 40 to 45%. The teams that were the early adopters were the teams that had mostly static setup, static network infrastructure. The guys that would normally update their network infrastructure did not really adopt this solution initially. So we started thinking about how about to have a solution that deploys the network firewall in the same VPC as the application. So we came up with the design of this distributed model. All outbound traffic sent to the AWS Network Firewall for inspection, and from the AWS Network Firewall to the public subnet. And for inbound traffic, we have edge association, and traffic, we have a route table that also sends inbound traffic to the network firewall for inspection. And this is probably, we would say, is a simpler model, and there was no reason why other teams will not adopt this. We developed playbooks for this. We encouraged teams to use the AWS strict order rule instead of the default rule, because we found out that there are a few advantages of doing this. And then we put ourselves in a position where every solution that is being deployed, we are the ones to review and approve it. The last time I checked, there were about 140 network firewalls that are attached to policy. It's not really about the numbers, but the fact that, imagine if we are still the ones managing this network firewalls. So I'm going to go through a few use cases from our service teams and our dev teams. So these guys here, they manage a platform that for testing different components of the Workday application. And their requirement is pretty basic. They needed an application level inspection and application level login, something beyond what they could get with the AWS security groups. And they practically just had to create an extra subnet for the AWS network firewall, and then routed all outbound traffic to the AWS network firewall for inspection. And they're able to get the application level inspection and login which they wanted. They also have some custom suricata rules, and they utilize the AWS managed rules as well. This other team, they manage the platform for installing software based on Kubernetes and Helm. So you will expect that there will be different types of nodes, worker nodes within their infrastructure. And their use case is for outbound filtering based on the real IPs, and then inbound filtering on the internet based on the real IPs as well. But because they have all their workloads deployed in the private subnet, and they have client IP preservation enabled on the network load balancers, for them to not go into a risk of hairpinning, they deploy 2 network firewalls in their infrastructure. This is okay by us. We don't really have a problem with that. They also build quite a few automations in their deployment. One is that they use the network firewall Kubernetes operator. What this operator does is that because the workloads change by IP addresses, so they created an IP set for the AWS network firewall policy, and this operator updates the IP set with the IP address of the workers whenever it changes. And they use network firewall controller to deploy the network firewall as well. There's also another use case for, they work in conjunction with our threat intels team to block certain IP address inbound to the infrastructure. So there's a lambda function within the network that kind of updates these IP sets whenever the IP address changes. Going forward, we are currently using the AWS Firewall Manager and the Resource Access Manager to share rule groups and policy within our organization. And the idea is that we have this as a single source of truth for all environments, all our deployments within the organization. And in case of a 0-day, for example, we could enforce policy to all the network firewalls deployed within the organization. We continue to make improvement on the Suricata rule groups, and we hope to start utilizing some of the newly supported features in the AWS Network Firewall, for example, the tag-based resource group, inbound TLS inspection, and then support for symmetric routing. We also hope to start using the geo-IP blocking when it's supported. And then we continue to engage the AWS solution architect. I invite you. Thank you.
Thank you, Buzu. And now, the last slide, really. If you can't remember anything else, rather than the picture you took before, I want you to remember this, right? That's all we need today. So first of all, use security groups, right? You guys are probably already using it, but use them explicitly, rather than just 000, open everything, I'm using a security group. No, please. Have them, specific network configured. If you need to centralize your management for most of the solutions, like you've seen they're supported, WAF, network firewall, security groups, if you need to centralize that, firewall manager is probably the way to go. Simple, supports a bunch of solutions, so go for that. Then, as you've seen in this session, different firewalls, different architectures of those firewalls will give you different features. So start from your requirements, what you need from your security teams, work from there, and you surely find a solution. Then, as Tsuri mentioned, we want you to start protecting as early as possible. So start from the edge. Don't let the threats get deep, right? So start there, and on top of that, protect in multiple places, right? So start at the edge, then in the edge of your VPC. For example, use security groups and network firewall. Use security groups and network ACLs. Don't stick to a single one, and protect as early as possible. And lastly, of course, if you have non-HTTP traffic, right, just focus on network firewall, gate load balancer with third-party firewalls, right? So this is there are 5 takeaways that I want you to take with you home and apply. And that's all, folks. Thank you.